Good morning to my lecturer, Quang In Tang Tina Chai. Today I want present about trigonometry in sport badminton. My group member is me, Iwei Cheng, Muhammad Ashari, Fitri bin Rosli, Muhammad Shami bin Ismail, Muhammad Rajin bin Sharu Anwar. Then I want to explain about the content table. The content table has introduction, realized application, formula, trigonometry, question, solution, retry of model, mathematics solution with drawing, conclusion, reference, and credit. After that, I want to present about the introduction of trigonometry badminton. In trigonometry, the span of mathematics content with specific functions of angle and their application to calculator. There are 6 functions of angles commonly used in trigonometry. Their name and abbreviations are sin, cosine, cos, tangent, tan, cotangent, cos, secant, sec, and cosecant, csc. Before that, I want to talk about the trigonometry in badminton. First, the effect of hitting the shuttlecock is dangerous. No matter how hard you hit the shuttlecock, it will not go much faster than about 6 or 7 meters. The terminal speed appearances by the course when it is under the influence of gravity is determined by the change of gravity, a descending the size and mass of the shuttlecock, and this smoothness. A parabola is spawned when we hit the shuttlecock. Its fate is far steeper than while rising. From a mathematical point of view, the total radius of a shuttlecock are a function of mathematical functions. Then I want to talk about the information for this light application. First, trigonometry can be applied in various ways in the context of badminton. Here are the few examples. For example 1, short pavement. Trigonometry can help players demonstrate the ideal angle and trajectory to place their shots. By understanding the angles and descent in which players can strategically aim for specific area for the course, making it hard for their opponents to return the shallow cut effectively. For example, to cover later, trigonometry can assist players in optimizing their movement on the court by calculating the angles and distance between different positions. Players can demonstrate the more efficient path to search the shallow cuts, ensuring they are in the right position to make a successful shot. For example, 3 Smith technique. Trigonometry can aid players in executing powerful smashes by analyzing the angle of the shallow cuts. Those players can adjust their body positioning and swing to generate maximum power and accuracy, resulting in a more effective smart shot. After that, for example, for search payments, trigonometry can help players strategically face their servers by understanding the dimensions of the code and the optimal angles. Players can aim for specific corners of areas, making it challenging for their opponents to return the servers effectively. Overall, trigonometry can enhance players' understanding of angles, distance, and trajectory, allowing them to make more informed decisions and execute shots with greater precision in the game of badminton. In addition, I also can talk about formula trigonometry. We can see about the formula trigonometry. The example for formula trigonometry has seen. Formula sin is sine opposite per hypotenuse. For formula cos is sine adjacent per hypotenuse. For formula tan is 6 opposite per 6 adjacent. For formula CSC is hypotenuse per side opposite SEC is hypotenuse per side adjacent. After that, for formula code is side adjacent per side opposite. Then we can see about the trigonometry reduced. We also have sin, cos, tan, cosec, sec, cot. For the formula, sin is opposite per hypotenuse. For formula, cos is adjacent side per hypotenuse. For formula, tan, tangent is opposite side per adjacent side. The formula cosec is 1 per sin. The formula sec is 1 per cos. For formula cos is 1 per tangent. At the point, let us see about a question about trigonometry. Let me see. For example, find the difference angle for theta 158 degree. In the solution, theta is 158 degree is in second quadrant. Different angles alpha is theta is 180 degree. The answer is 22 degree. For example, exercise 1, trigonometry 1a. The question is sin 155 degree. The answer is 0.423. For question 1b is cos negative 55 degree. The answer is 0.574. For question 1c, 205 degree. The solution is 1 per cos 205 degree. The answer is negative 1.103. For question 1d, cosec degree 166. The solution is over sin 166. The answer is 4.134. Let me see one. Let me see question 2a. The question is sin theta. The solution is 0.5634. The answer is theta is sin negative 134.291. For question number 2b, cos theta is constant and is 0.5691. The solution is theta is cos negative 0.5691. The answer is 55.31 degree. For question number 2c, tangent summerton 1.511. The solution is tangent negative 1.511. The answer is 56.50 degree. 2. For question 2d, 2 seconds theta equal to 5 seconds theta equal to 5 over to 2. 1 equal 1 over cos theta equal to 5 over 2.
Powerful smash from midcourt will have an almost straight trajectory represented by a function such as Ax plus by plus c equals to 0. A backcourt drop should let y equal to arctan x. A long serve can be represented by the following function: y equal to 5 sin x. The trajectory of a backhand short serve has a function of y equal cos x. A hairpin drop looks like y equal 5 sin 2x. Although it may not seem like it, position and positioning on the pitch are crucial as a player. I will discuss how to use sine, cosine, and tangent to find the perfect angle for a bird to be at the back of the course as it flies toward you. Although it may not seem like it, position and positioning on the pitch are crucial as a player. I will discuss how to use sine, cosine, and tangent to find the perfect angle for a bird to be at the back of the course as it flies toward you.
This is our model. It made by a cardboard. It came as a trigonometry mat in the badminton match. Although it may not seem like it, is the position and the positioning on the pitch are crucial as a player. I did discussion how to ask sin, cos and tangent to find the perfect angle from a bird to beat the back of the course at a fight toward you. Something to know before we get started. A standard futsal badminton court is rod 44 x 20 feet. Half the course width is the space asked by one pair or single player in the game, would then be 20 x 16 feet. Those are the dimensions it will be asking to solve the problem. The solution: theta equal tan negative 1. 16 per 20, we get the 38.66 angle to
Simpan lah.
tak apa lah kalau tak.
Conclusion about trigonometry is very simple but useful tools that we use in sport to calculate distance and angle, so that we can know how far we need to go or know the direction in which we should hit the ball. Trigonometry is a branch of mathematics that deals with the relationship between the angles and sides of triangles. While it may not be immediately evident, trigonometry has application in various fields, including sports like badminton. Individual players often need to calculate angles and distance to make accurate shots and strategic moves on the court. Trigonometry can be used to analyze and optimize shots, especially when it's come to understanding the trajectory and angle required to clear the net or hit the shuttlecock. With predication, for example, player can use trigonometric functions such as sin, cosine and target to determine the optimal angle to hit the shuttlecock for a particular shot. By understanding the relationship between the angle of elevation, the distance to the target, and the speed of the shuttlecock, players can adjust their shot to achieve the desired outcome. Additionally, trigonometry can also be useful in analyzing the geometry of the badminton court. For instance, calculate the distance between players or the position of the shuttlecock relative to the boundaries of the court can help players strategize their movement and anticipate their opponent's shots. In conclusion, trigonometry play a role in the sport of badminton by helping players understand and calculate angles, distance, and trajectories. By applying trigonometry principle, player can enhance their shot accuracy, optimize their gameplay, and make strategic discussion on the court. Conclusion about trigonometry is very simple but useful tools that we use in sport to calculate distance and angle, so that we can know how far we need to go or know the direction in which we should hit the ball. Trigonometry is a branch of mathematics that deals with the relationship between the angles and sides of triangles. While it may not be immediately evident, trigonometry has application in various fields, including sports like badminton. Individual players often need to calculate angles and distance to make accurate shots and strategic moves on the court. Trigonometry can be used to analyze and optimize shots, especially when it's come to understanding the trajectory and angle required to clear the net or hit the shuttlecock. With predication, for example, player can use trigonometric functions such as sin, cosine and target to determine the optimal angle to hit the shuttlecock for a particular shot. By understanding the relationship between the angle of elevation, the distance to the target, and the speed of the shuttlecock, players can adjust their shot to achieve the desired outcome. Additionally, trigonometry can also be useful in analyzing the geometry of the badminton court. For instance, calculate the distance between players or the position of the shuttlecock relative to the boundaries of the court can help players strategize their movement and anticipate their opponent's shots. In conclusion, trigonometry play a role in the sport of badminton by helping players understand and calculate angles, distance, and trajectories. By applying trigonometry, principal player can enhance their shot accuracy, optimize their gameplay, and make strategic discussion on the court.